All right, let's get this show on the road. Okay, guys, probability and permutations, 19.2. It is a pretty easy section. Um, well, I don't know. The math is really easy. This is like your introduction to stats. So if you take my stats class next year, this is the kind of stuff we'll be doing for the whole first semester. And then hopefully the second semester we will be back to normal and you guys will come to class and we'll make board games, but I don't know. Sad. Anyways, probability. So probability is all about, so there's a general formula for all probability. It is the number of things that you want divided by the number of things possible. Okay? It's this simple equation, right? We just have how many ways can something happen that we want versus how many ways are possible. And so the trick with this is figuring out how many of each of these there are. So the first thing I'm going to do is they introduce you in the book to something called the fundamental counting principle, which is just a really fancy way of, it is a shortcut for counting things. So we're going to start with 2 dice. Hey, look at that. I got doubles. Which there has been so much math done on dice because they use them for all kinds of stuff. I still haven't gotten a 7. It's crazy. Nope, still no 7. Nope. Anyways, there are lots of possible ways that these dice could roll out. Okay? But say you wanted to figure out quickly, like, well, how many ways could it be? I'll show you. Well, first I'm going to show you the long way. Okay, so I'm going to write it out. So we have 2 dice, right? So it won't take that long. But so on that first dice, I could roll a 1, right? And on the second dice, I could roll a 1. Or maybe I roll a 1 and a 2. Or a 1 and a 3. Or a 1 and a 4. Or a 1 and a 5. Or a 1 and a 6. Hey, that is all the ways, all my possible options if I got a 1 on one of the dice, on the first die. Well, what happens if I got a 2 on that first die? I don't know. Let's see. Say we got a 2 and then a 1. And a 2 and a 2 and a 2 and a 3 and a 2 and a 4 and a 2 and a 5 and a 2 and a 6. Look at that. It's still 6 numbers, right? And then so, okay, but that's all the possible ways of getting a 1, all the possible ways of getting a 2. Well, let's see. The next one would be 3. So we have 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. Halfway done. Or am I? I am. Okay. So I'm going to just kind of go through. I hope at this point you see the pattern of what I'm doing. I'm listing all the possible things I could roll on 2 dice. Okay? It's very systematic in the way I do it. And the reason is you see all kinds of weird, cool patterns start to show up if you set it up this way. But that's something for another time. But anyway, so I have all my 1s, all my 2s, all my 3s, and now I'm going to do 4s. 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6. Okay, and then let's go to 5s. 5, 1, 5, 2, 5, 3, 5, 4, 5, 6. Oops, I missed one. 5, 5, 5, 6. And then last but not least, I'll use orange. The 6s. 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. Okay, so I just made a very pretty rainbow array of all of the possible rolls of 2 6-sided dice. Okay, so that first column is my first die. Second column is my second die. So if I look, the first die, I could roll a possible 1, 2, 3, 4, 5, or 6. On the second die, I could roll a possible 1, 2, 3, 4, 5, or 6. So that means it's 6 times 6, which is 36. So I just listed out 36 possible configurations of rolling 2 dice. Okay? Now I'm going to show you the shortcut, which you'll be like, thank you, I don't want to do that, which for this, it's not terrible, or 2 coins, it's not terrible, but later on, you get problems that are like, well, how many possible ways could you arrange 8 things or 9 things or 14 things? No, you don't want to do this. No. This is called the fundamental counting principle, and it has to deal with, so one of the things I actually really like that the book uses, they talk about this box property or box method. And so the box method is, say, how many things am I rolling? Well, I'm rolling 2 dice, right? So I'm going to make, they use boxes, I just do lines. So I have 2 blanks, 1 for each die. Well, how many possible things could I roll on that first dice? Well, I could roll 1, 2, 3, 4, 5, or 6. So I put a 6 there. How many possible things could I roll for that second dice? Well, 1, 2, 3, 4, 5, 6. 6 things. Okay? So it's important to note that when I say 6 things, I don't necessarily mean the 6th thing. I mean there are 6 possible things I could roll. There are 6 options. So to figure out the total number of possibilities, I'm just going to do this. What is 6 times 6? It's 36. Boom. That is the fundamental counting principle, and it is super key to this. I have to pause for a second, and I'll rejoin in a minute. All right, and I'm back. So anyways, this is a great example of, again, it's called the fundamental counting principle. You don't really need to know the name of it, but it's just a really quick and easy way to figure out the possible, how many possible ways something could shake out. And the name, the fancy name for how many possible ways something could shake out is called permutations. So what I just did was I gave you all 36 possible permutations. There's a 7 possible permutations of those 2 dice roll. Okay? So again, fancy word for something that is really just different, not combinations, because in statistics, combinations mean something different. 36 different permutations. Okay, so now I'm actually going to kind of skip through, well, no, you know what? I'm going to show you the formula for permutations. So no, not yet. I'm going to do more box method stuff because I think the box method stuff makes a lot more sense at first. And then I think you need to know the formula for the next section, which is combinations. Okay, so I'm going to go straight to my gray sheet. Okay, so we're going to work through this first problem because I feel like you just need to work through something. So get out your gray sheet, work through this with me. Okay, so we're going to use that box method or the blank method. That's what all of this mess is up here. That's what all these boxes are standing for. Okay, so using that example I just did for the 2 dice. So a jewelry store clerk chooses 4 pieces of jewelry to display on his shelf, or on a shelf, okay? So I have 4 pieces of jewelry I'm choosing. So that is the number of dice I'm rolling, right? That is the number of spaces I'm filling. So that tells me that if I'm drawing out my diagram to figure out what my number is going to be, I'm going to draw 4 blanks. Okay? That's the first. Oh, hey, look at that. I lined it up with number A, letter A. So use the space above to draw the appropriate number of blanks. Boom. 4 pieces of jewelry, 4 blanks. Done. The clerk will choose the 4 pieces randomly from a group of 8 pieces. Solve for NFS, total number, blah, 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 whatever. 8 pieces. So essentially, I have 8-sided dice. Give me a second. Okay, I don't really need an 8-sided dice, but why not if I have them? Where are you, 8-sided dice? There we go. 8-sided die. Okay, so what I'm doing is I'm choosing from those 8 pieces. So if I were to randomly choose something, well, think of it like a die. If I were to randomly roll a die, how many possible numbers are there for me to choose from? I'm not putting them in a list and saying the 8th item is the gold necklace. No. All I'm saying is how many possible things could I grab if I were to stick my hand into a bag and randomly get a piece of jewelry, right? So on that first one, I have 8 possible things I could grab. That's it, right? Everything's there. I haven't picked one yet. Okay? So then after the first piece is placed, how many options are for the second one? Well, if I've placed one of the 8, how many are left? Because I can't pick that one again. Again, we'll do some more. Since I have all my stuff here, let's do some more physical examples. There's 4. There's another 4. There's 8 dice. So let's say I randomly pick one and I pick this guy. Boom. So I picked that one. how many different dice do I have left? 1, 2, 3, 4, 5, 6, 7. I have 7 things to choose from. That's really all you're doing. So after I chose 1, it goes down by a number and it becomes 7. Take a wild guess. What is the next number going to be? Now how many things do I choose from? It's 6. Hopefully you're starting to see how this works. 6, and then the last number, 5. Okay, so that's where this blank method is really awesome and powerful, because it basically automatically does the fancy formula that they use up. No, they don't even show you the fancy formula in this, but it uses the fancy formula without having to use a fancy formula. It's just kind of common sense. Okay, so we basically just did A, B, C, and D. And so now the last step is just to figure out, well, what number is this? Oh, I don't know. Get a calculator, multiply it. Where is my calculator? Calculator. 8 times 7 times 6 times 5. 1,680. That's it. 1,680. Boom. 1,680. Okay. There is 1,680 possible permutations of picking 4 pieces of jewelry from 8 different things. So like again, there is 1,680 possible ways for me to pick 4 dice from these 8. There is 1,680 possible ways for me to pick who had 8 movies. I don't remember who had 8 movies. Cap had 7. Who had, I don't remember. We'll say Black Widow. I think Black Widow might have had 8. I think Black Widow had 8. I have no idea. So there is 1,680 ways to watch 4 movies that have Black Widow in them from the MCU. It doesn't matter. Like, really, it's just blanks and you're filling stuff in. Okay, so that is the basics of probability and permutation. Let me pull up the white sheet. Let's do some of this stuff. Okay, so here we go. Here's the fancy, crazy stuff. Now they give you the equations. Now they give you these weird 5 exclamation points. No, it is not a 5 that is yelling. This is called a factorial. Okay, so essentially what we were just doing with that, if you noticed, it had a pattern. It went 8, 7, 6, 5, and we multiplied it together. Factorial is a fancy way of basically, it's a shorthand of writing that sequence. So 5 factorial is just 5 times 4 times 3 times 2 times 1. You just multiply all those numbers together. So 6 factorial, which would be 6, 5, 4, 3, 2, 1. 7, 6, 5, 4, 3, 2, 1. Okay, now let's get into these other ones. And this is where the equation comes in. Okay, so now we're going to go back down here. So the equation for permutation looks like this. NPR. Okay, NPR, so this is the total number of things, and this is the number that I'm choosing, and the P stands for permutation. So the difference between permutation and combination, which I hinted at earlier, is that in permutation, order matters. So an example of a permutation would be a race. Say there are 10 runners. It matters who comes in first, second, and third. It matters if, let's see, I'm trying to think of people in the class. Rebecca gets first place, and Chloe gets second place, and Tyler Williams came back and got third. That would be different than if Richie got first place, Callie got second place, and Michael got third. Again, order matters. So that's permutations. So the flip side is combinations, which is where order doesn't matter. So like, for example, that was like if I was picking, how many combinations are there of me to pick 3 people from class? If I picked Marley, Elise, or let's do the Elisas. So Elise, Elisa, and Celise. If I picked all 3 of them, it doesn't matter who I picked first because I picked all 3 of them to go get free ice cream or something. that's a combination. So we're talking permutations now. Anyways, that's a lot of stuff. So n is the total number, r is how many I'm choosing. So here's what the formula looks like. It's a lot easier than it looks. So it is n factorial over n minus r factorial. Oops, parentheses. Okay. So I'm going to do that problem I just did with the necklaces or the jewelry and 4 spots. So if I were to do that problem, let's flip this page. And this is why I said the box method or the blank method is so useful, because it basically skips that equation and you just kind of do it. But anyways, I want to explain factorials and all this stuff, and the equation helps a little bit. So again, it was NPR, and this is total number, and this is number chosen. So for that example of the jewelry that was on the gray sheet, I had 8 total pieces of jewelry and I was choosing 4. So the way I would write that would be 8P4, right? Because I have 8 total things, I'm choosing 4. So the equation again was n factorial over n minus r factorial. Okay, so 8 choose 4. So here we go. If I were to work this out, this 8 is the number that goes on top. It should always be the bigger number on top because you should never have fractions with these. Okay, so I have 8 factorial on top. And on the bottom, it would be n minus r. So it's going to be 8 minus 4. So 8 minus 4 factorial, okay, which becomes 8 factorial over 4 factorial, which looks really crazy, but I'm going to write it out and show you that it's actually really easy math once you see it. Okay, so remember, 8 factorial is just 8, 7, 6, 5, 4, 3, 2, 1, all multiplied together. 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Right? That is the same thing as 8 factorial. Okay, and now I'm going to do 4 factorial on the bottom. 4 times 3 times 2 times 1. So now the reason I say this is way easier than it looks scary. It's like a bazillion numbers. But look, I have a 4 down here and a 4 up there. So they cancel out. I have a 3 down here and a 3 down there. So they cancel out. And I'm left with 8 times 7 times 6 times 5. Which, in case you don't remember, what was the answer to that problem? 8 times 7 times 6 times 5. Okay, so again, just to reiterate, that's why I think this blank method is so nice, but you need to understand how the permutations work. So if I go back to this guy, back over here, 6 and 5, so that's going to be 6, 5, 4, 3, 2, 1, divided by 5, 4, 3, 2, 1. You cancel stuff out. Done. Okay, there was one on here that someone had a question about, I remember. Number 13, the playlists, songs. Okay. So most of these can all be done with that blank method. So like if I look at this one, how many things could I possibly choose for tour? 3. How many things could I possibly choose for restaurants? 2. How many things could I possibly choose for hotels? 4. So that's 3 times 2 times 4. Done. Okay. On to the more tricky one. Number 13. Okay. So it says Kim has a playlist of 8 songs. And it includes her favorite and her second favorite song. She wants to know, first, how many possible ways could I shuffle those 8 songs? Well, how many songs am I going to play? I'm going to play 8. How many songs are there? There's 8 songs. So this would just be 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. It is that many songs, which is a lot, which is why we say 8 factorial. It is 8 factorial songs. Okay, here's the tricky part to this one. So I'm going to write my 8 boxes. 1, 2, 3, 4, 5, 6, 7, 8. Let's go back to my dice. Maybe it's just me, but I feel like they make things make a little more sense. We got 4, I need 1 more. 8. Okay, so let's say this is my favorite dice. How many options do I have for choosing my favorite dice? Well, that's my favorite dice, so I only have 1 option. So that means for my first song, because she wants, how many ways could she have it with her first song favorite? Well, okay, so I have one thing I could choose. So that's my first favorite song. Okay, now I want my second favorite song to be second. Let's say my second favorite dice is this one. So how many options do I have to pick my second favorite dice or song? Well, there's only one. So look, we have another one. And then after that, I don't care. We don't care what they are because usually by the time those first two songs have played, I'm at work, and so I don't care what the rest of the songs are. Or I'm at school, and so I only care about those first two songs. I don't care about the rest. You can eat the rest of the cake. Look, look, look.
No.
It's cake. I'm going to eat a bite.
Stop it. No. Dad, that was a big bite.
Oh, not a big bite. Look at that. There's still a ton left. There you go. Move away. I'll eat the rest. Do you want me to eat the rest?
It's like a quarter.
Who ate the rest of that cake?
You.
Yeah, she ate it.
It was a tiny cake.
She's greedy. Okay, anyways, back to this. So I picked my first two. After that, I don't care what song comes next. So I have 1, 2, 3, 4, 5, 6 different options. And I don't care which it is, so it's going to be 6. So let's say it's this one. Now how many do I have? 5. Now how many do I have? 4, 3, 2, 1. So that means there are 6, 5, 4, 3, 2, 1 possible ways that I could make a playlist that has her first favorite song, then her second favorite song. So that would be 6 factorial. Okay. Hopefully that makes a little sense. And so with these, it's all about figuring out what they're asking and filling in those blanks accordingly. But that's really it. Let me see. Is there okay, so probability. So this one's asking for probability. So if I remember, I think I got rid of it. Probability is all about how many ways is it possible for something to happen, 8 factorial, versus how many ways does the thing you want happen, 6 factorial. So this one, that's the number desired, that's the number possible. So it's going to be 6 factorial over 8 factorial. Okay, which I've already got all the numbers here, so I'm going to start canceling out. So let's write this up. So it's going to be, so this one, so I know earlier I had said that the bigger number should always be on top. That's if you're looking for the number of permutations. If you're looking for probability, it's actually flipped. The way to remember it is the number of permutations possible. That's always a whole number. I can't have a third of possible ways to flip 2 coins. But the probability, that is always a fraction because I very rarely do I have a 100% chance of anything happening. Okay, so it should always be less than 1. Anyways, so I've got 6 over 8. So that means I'm going to be canceling out on this guy 6, 5, 4, 3, 2, 1. And I'm left with, 6, 5, 4, 3, 2, 1. So on the bottom, I have 1 over 8 times 7, or 1 over 56. So I have a 1 in 56 chance of this situation happening. Okay, probability, done. Yeah, if you have any more questions, bug me. But that's it for now. Have a good night, guys.